Welcome to the Firefighter's Achilles Heel, Anticipating Wind Shifts. This presentation, given during the National Weather Service Seattle's 2016 Annual Fire Weather Users Meeting, was compiled by Andy Hayner, Fire Weather Program Leader and Incident Meteorologist for the National Weather Service Forecast Office in Seattle, Washington. In looking at entrapment fires, meaning fires in which fire shelters were deployed, from 2000 to the present, some similarities start to emerge. For those listed here, weather was a contributing factor in each one. To expand on that, we can see the most common weather factor is that of a wind shift. Other commonalities include that every one of the incidents listed was less than 24 hours old at the time of entrapment. Only 2 of these 5 incidents had spot forecasts, and most of these incidents were within cell phone range. Take note that the 2 latest entries here, the Frog Fire and the Twisp River Fire, did not have spot forecasts. Through this comparison of what each of these entrapment fires had in common, 3 points stand out. Sharp and sudden wind shifts, entrapments being most common on new and emerging fires, and that these occur often before a spot forecast is requested. That said, a potential solution arises from the very first standard firefighting order. Keep informed on fire weather conditions and forecasts. Here are the usual causes for these wind shifts: thunderstorm outflow, cold fronts and marine pushes, and the foehn winds. Each one of these can give rise to sharp, sudden, and fast changes in both wind direction and wind speed. Let's start off with the classic wind shift associated with the passage of a cold front, where, if you remember from the S290, winds will come from the south to southeast ahead of the cold front, meaning that the front has not passed your location yet and you're still within the warm sector of the low. Once the front passes by, the winds shift to a more west to northwesterly direction. An important thing to remember is that as the front passes and immediately behind the front is when you're going to experience the peak wind speeds. The marine push behaves very similar to a cold front. Cooler air behind the marine boundary and warmer air ahead of it. As such, the wind effects are very similar. With both cold fronts and marine pushes, these are phenomena that forecasters can predict pretty skillfully. As such, any spot forecast you request will likely highlight a wind shift by either of these mechanisms. Next up, thunderstorm outflows are part of the anatomy of a mature stage thunderstorm. As downdraft winds reach the surface, these cold, moist winds rush outward away from the storm, creating outflows and gust fronts. Wind speeds associated with outflows can reach in excess of 60 miles an hour. Visual indicators of the presence of thunderstorm downdrafts include virga, where you can see cloud bases that have a ragged appearance. While the surface level may be too dry for rain to actually make it to the ground, virga shafts can certainly tell you that there is air rushing down toward the surface and thus the potential for outflows. Rain shafts, similar to virga, display that air is rushing down to the ground, again highlighting the potential for outflows to be present. Unlike virga, however, rain is indeed making it to the ground. While not always this dramatic, dust clouds, sometimes called a dust foot, or dust storms with particularly strong outflows, are also good visual indicators of an approaching outflow or gust front. As you watch the radar loop, take note of where the storms are and the thin lines that move away from them. These are how the radar sees outflows. And with cell and data coverage becoming more and more widespread, the use of the internet or weather apps with radar imagery can also be a good visual indicator. Now let's see how outflows appear on radar imagery. Here we have a classic example, a large thunderstorm with a thin, ring-like line rushing out in front of it. While the previous example had a line that only partially surrounded the thunderstorm, here we can see that the outflow can spread in all directions from its parent storm. Now that we've seen some really clear-cut examples, let's take a look at how stealthy some outflows can be. Here we're looking at radar imagery from the entrapment that occurred on the Beaver Fire. One arrow indicates the location of the fire and how the radar is picking up the smoke. The other arrow points to a faint line that is actually an outflow from a thunderstorm east of the fire's location. As the very faint line from the outflow moves west, continue to watch the smoke plume, which is, at this time, still moving in a northerly direction. At 5:37 p.m., the time at which the entrapment occurred, you can see on radar that the outflow has moved over the fire, resulting in the smoke column being pushed away from its northerly direction and is now moving westerly. While the 30-30 lightning rule has become generally accepted, it might be time to consider a more cautious approach. Consider instead that outflow winds may continue to be a threat for 2 to 3 hours after the last thunder associated with the storm has been heard. This is especially important if initial attacking a new lightning start. The rationale for this is that outflow winds can come from storms that are too far away to be heard or maybe too far away to be seen through smoke. Now we move on to foehn winds, or as we know them here in western Washington, the east winds. Although, as you can see from this slide, if you find yourself in another part of the country, these winds may be called by another name, most famously the Santa Ana winds down in Southern California. So how do east winds come about? High pressure needs to set up over southern British Columbia. On its first day, the wind is actually more northeasterly. One specific instance of this is what's called the Fraser outflow, named for the Fraser River Valley that helps to channel and accelerate the winds. In winter, this is usually associated with very cold temperatures, but during the summer, it's a hot, dry foehn wind. When those northeast winds kick in, the locations you see outlined in red are the most prone to red flag conditions. On days 2 and 3 of an east wind event, the high dips down into eastern Washington, setting up a pressure gradient over the Cascades. This allows for a dry, warm wind to come down off the Cascades and into western Washington. Here, once again, we show that as the wind direction shifts to more easterly, so too does the location of red flag conditions. Some important things to keep in mind regarding the east winds. They're more common during the second half of fire season, generally from about late August until the end of the season. They typically affect relatively small, localized areas in the region. They can develop rapidly. They bring lower RH and warmer temperatures, and these east winds can persist through several operational periods. Now, what happens when you find yourself east of the Cascades? Well, it turns out that you've got a diurnal wind shift to be concerned about. Let's step through the typical day to show you how this develops. We start here at 11 a.m. By this time in the late morning, normal up-valley winds have developed, as you can see by the red arrows here. As we get into the afternoon, or in this instance 1 p.m., you can see that the daytime heating over eastern Washington has created low pressure at the surface. Conversely, the cooler marine air over western Washington has resulted in the development of surface high pressure. This results in the development of a pressure gradient right over the Cascade Ridge. With airflow between pressure systems going from high pressure to low pressure, we see that by late afternoon or early evening, the pressure gradient has resulted in the up-valley winds shifting nearly 180 degrees as winds from western Washington now rush toward the low pressure on the east side of the Cascades. If we look at windroses associated with RAWS stations on the east side of the Cascades, we see evidence of this shift. Here, looking at Camp 4 between noon and 1 p.m., we can see that climatologically, winds are typically from the southeast. Forwarding in time to between 5 and 6 p.m., however, we see a climatological shift to the northwest. We mentioned earlier that half the entrapment fires looked at to create this presentation did not have spot forecasts at the time of entrapment. Now let's take a look specifically at the Twisp River fire as we discuss sources of weather information. There's a lot to read here, but the second paragraph contains what we'll be focusing in on. Most resources on the fire, including the ICs, only had access to the general fire zone forecast. Some resources that had been reassigned from surrounding incidents to the Twisp River fire still had their specific weather forecasts from the Chelan complex. Let's compare and contrast what we mean by general zone forecast as compared to specific weather forecast. The general zone weather forecast issued that morning covered all the zones you see highlighted here in red. That's the entirety of northern Washington, from the Cascades to the Idaho Panhandle. Is this the best forecast to base containment efforts on? Not when locally tailored specific weather forecasts or spot forecasts are available. Here we can see the forecast those reassigned resources had access to. And sure enough, as you can see highlighted in yellow, attention is called to wind shifts, not only what direction the wind will change to, but about what time crews out in the field can expect the shift to occur. So to emphasize, getting a spot forecast is key. Forecasters in the Weather Service office can tailor a spot to suit your needs and your specific location, and that includes taking into account any small-scale weather effect that will impact your particular incident. Something to keep in mind, if you think control efforts will take more than 2 hours, then don't hesitate. Get a spot forecast. Remember, no observations are needed for a first-time request. Spots are typically available 20 to 30 minutes after we receive your request, and are often requested through dispatch. Remember that your spot request needs to include a callback number. This way, if forecasters see something that isn't behaving according to the forecast, they can reach you to relay the information as quickly as possible. You can also call a forecaster to talk about upcoming weather trends. To reach the fire weather desk at the Seattle office, serving most of western Washington, call area code 206-526-6088. This number is unlisted and is supported 24 hours a day, 7 days a week. For other fire-related forecast products, including our YouTube fire weather briefings, you can head to weather.gov/Seattle. Then either look along the menu on the left side of the screen and click on Fire Weather, or click on the Fire Weather tab above the Watch Warning Advisory map. Either way, it'll take you to our main fire weather page, where you can find links to the latest fire weather zone planning forecast, our latest YouTube briefing, as well as our spot forecast request page. Going back to our main page, you can also get forecast based on what city you are in or close to from the drop-down menu circled here. Doing that brings you to a forecast with icons and detailed text. If you want to change your location, use the Google map on the right highlighted here to do so, simply by clicking on the map where you'd like your forecast for. Once you've got your position, look at the bottom right-hand corner and you'll see the hourly weather forecast. This gives you hourly weather graphs for the location you've set. While it's a little small in this screen, if you click on it, you can see in much greater detail what these weather graphs provide, an hourly breakdown of the major weather features that you can turn on and off from the menu at the top. While this does not replace a spot forecast, it is the next best thing. If you feel you should need a weather consultation, feel free to call our unlisted fire weather line, area code 206-526-6088. During fire season, from 7 a.m. to 5 p.m., this line is manned by a forecaster solely focused on fire weather issues for the day. Should you call outside this time, however, don't worry. You will still get a live forecaster that's qualified to discuss the forecast and any concerns you might have. If you have any questions pertaining to our fire weather program, you can email our fire weather program leader, Andy Hayner, at the email address listed here. Some smart questions to ask when talking to a forecaster might be, will there be a wind shift in the next 4 hours? Or will the wind shift be sudden or gradual? While the forecaster will attempt to answer any weather question, the more specific you are about what you need to know, the better the forecaster will be able to serve you. Thanks for your attention during this presentation. If you have any questions on the material presented here, feel free to email Andy at andrew.hayner@noaa.gov.